So I'm going to be talking to you today about how blind programmers in general may have given us some sort of accidental insight into how we design computer programming language tools. Work that I'm doing in collaboration with Chris Unghausen from WSU in the back. So here's the first lesson you need to know about working with blind individuals. These guys face, and gals face, challenges that many of us do not. In fact, many of the tools and technologies that are around for blind individuals either A, don't work at all, or B, they work very poorly. So for example, while some tools like Microsoft PowerPoint, which doesn't actually work on Mac for the blind, IDEs for the blind work much, much worse. For example, often many of the tools and techniques inside of these don't work. And it just gets worse when you start to move to work in visualization environments. While these sort of tools have been very popular for a long time, you simply can't download a version of Alice that magically works for the blind. And commercial tools like Unity 3D are massively worse. They're just completely inaccessible. So we thought, what if we have blind students just use programming languages and we ask questions about that? Like, does syntax matter to the blind? Does a programming language read well through a screen reader? And it turns out that the answer is basically no. And so the second lesson that you need to know is that syntax is much, much harder to understand through audio than it is through a visual stimulus. So let me give you an example. If you think about just common C-style syntax, like a loop, many of us in this room can look at that top phrase and know what it means, but on the bottom it translates to for int I equals 0, semicolon I less than 10, semicolon I plus plus right parallel left brace, which is about maybe a quarter of the speed that a blind person might read that. And so we thought, what if we had a radical idea to actually use common English in programming language, get rid of all the nonsense characters, be terse but clear, and we thought maybe that would make it a little bit easier for a blind person to understand what's going on. Right? So then we changed the slide to something else. I don't know what happened there. So we invented other IDE tools, which actually run an innovation award for, which was a talking debugger, basically. And this debugger used a comprehension analysis technique to try to figure out which cues to say, like what to say to a blind user. And it turns out, we thought, well, okay, we spent all this time with the language, but do you think that this would make something easier for everybody? So we thought, well, why don't we just ask a bunch of people? So we went to novices and we asked hundreds and hundreds of novices, well, what do you think makes sense? And it turns out, universally, they say that we have no idea what we're expressing in programming languages. Like, for example, we asked about this and functions and null pointers, exceptions and throw. The three worst choices for loops were for, while, and for each, ironically. So we asked lots of questions, but at the end of the day, I think one reporter summed this up best, but this reporter was not a Finnish, by the way. And he said, programming languages aren't even Greek, they're Klingon. Right? So, asking people questions is nice, but it would be much nicer if we could get something more rigorous, some empirical studies, some better evidence on how people are using these things in practice. Remembering that we didn't really intend to do this at all. This is sort of accidental. It kind of fell out in the wayside. So we ran a couple studies. The first one, we said, well, let's take Perl, just a standard programming language. Let's take Quorum, the one that I made, and let's compare it to a control group. So what we thought to do was, let's just take all the syntax we've chosen carefully in Quorum, let's roll dice and come up with a language randomly and test it. So it turns out, people when they use Perl can do no better than a language designed randomly. Which sucks, but it gets worse, because we actually didn't believe this result right away, so we replicated it, and it's true for Java too. Unfortunately. And so, yeah, that's usually a punchline, so I'm glad you actually laughed. So the point is that even though we didn't really intend to work with blind individuals, sometimes they can give you info. And in this case, this technique that we designed for a debugger, it turns out not only can it predict stuff with languages, it can tell you which tokens cause the problem. So we actually know in Quorum which ones to remove when we go from version to version, because we just run a new study that tells us. It says there's a 50% probability of getting an integer right. Anyway. So one of our blind students who's actually using Quorum summed it up by saying, I've been looking at it, the syntax is just very simple to use, I can just remember most of the keywords, and it's not surprising because we've run these studies on hundreds and hundreds of people. Right? So here's the point. A lot of these BPC programs are designed to bring people together. Richard's work, the NC Unit work, all this stuff, and this is really important. But The other benefit of BP-style programs is sometimes you find stuff by accident. I mean, think about it. We've been designing these languages for what? We have what, 8,000 of these now? I think that's the actual number. Think about that. Maybe we can get just a little bit of evidence, maybe that'll help us in the long run. For everybody.